Minutes left. Okay, there's one more type of equation we want to look at from this section in your book. And it's new, but it's really old because everything in math is the same but different, but the same but different. So suppose I have this. X to the fourth plus x squared minus 6 equals 0. What type of equation is that? How would I solve that? Any ideas?
Combine like terms?
Are there any like terms?
No. Just put the x's together?
Can you do that? An x to the fourth and an x squared? You can only combine x's with x's, x squared with x squared, x cubed with x cubed. Those can't be combined. Is that a hand going up? How is this different from the ones we've done so far this semester? It's not cubed, that's a fourth power. It's actually quadratic. There we go, we know the term for it. How do you solve a quadratic equation? Okay, there is a trick to this. Your brain has done math your whole life. Yes? They start teaching you numbers when you're really small nowadays. And math is all about patterns, seeing things, recognizing things. And over time, if you do enough math, and by that I don't mean tons and tons and tons, I mean just being alive, your brain should recognize things, recognize patterns, things that it's seen before. If I gave you this, x squared plus x minus 6 equals 0, what's that?
Quadratic.
Quadratic. How would you solve it? You would factor it. Two numbers that multiply to x squared, well, that's x and x, which is actually the linear term, correct? And then two numbers that multiply to negative 6 that add up to 1, positive 3, negative 2. Correct? How is this different than that? Yes, it's raised to a fourth power. It's quadratic, not quadratic. But there's three terms, set equal to 0. The last term is a constant. The only thing different is these things here. But if you look at the powers, here we have the linear term, x to the 1. And when you square the linear term, you get the leading term, the quadratic. Here, if you look at the middle term, that's x squared. What happens if you square x squared? You get x to the 4th, right here. Which means they're actually the exact same. So while it is not quadratic, you cannot use a quadratic formula on it, it's what we call in math quadratic in type. It's kind of quadratic and you can solve it the same. Factor it. It's still going to be plus 3 and minus 2. That's what will give me the negative 6. But now, instead of having x be my middle term, so this is x and that's x, my middle term is x squared. So what goes here and here? X squared. You can pour that out and check. X squared times x squared is x to the 4th. X squared times negative 2 is negative 2x squared. 3 times x squared is 3x squared. 3x squared minus 2x squared is x squared. And then 3 times negative 2 is still negative 6. And you're done. Now it's set equal to 0. So do the same thing. X squared plus 3 equals 0. Or x squared minus 2 equals 0. Now you just have to solve both of those. Here, add 2 to both sides. You get x squared equals 2. Square root method. That's how we solved quadratics before, right? Square root both sides. X equals plus or minus root 2. Here, subtract the 3. X squared equals negative 3. Square root both sides. X equals plus or minus the square root of negative 3. Square roots of negatives are complex, imaginary, I, right? So this just becomes plus or minus root 3i. Does it make sense? When we solved quadratics, how many solutions did we get? 2. It's quadratic, raised to the 2nd power, you get 2 solutions. This is raised to the 4th power. How many solutions should I get? 4. How many did I get? plus or minus 3i, that's 2, plus or minus root 2, plus or minus root 3i, plus or minus root 2, 4. There's 4 solutions, I found all 4. Pretty easy? Ultimately, again, there is nothing new here. It's essentially solving a quadratic by factoring. It's just not a quadratic, it's quadratic in type. The only thing that really changes is this last step here, where you end up with an x squared, not an x. But that's one step right at the end. The rest is the same. You have to recognize the pattern. Suppose you have this. X to the 6th plus 13x cubed minus 30 equals 0. Is that quadratic? No. Is it quadratic in type? Well, check. There's 3 terms that equal to 0. That's constant. Take the middle term, x cubed. If you square x cubed, you get x to the 6th. So it's quadratic in type. Instead of having an x here, you have an x cubed. Then you just need 2 numbers and multiply to negative 30 that adds to 13. 15 and negative 2. So you get x plus 15, x cubed minus 2. Set both equal to 0. Instead of square rooting, this time you'd have to...
Wouldn't it have to be x to the 9th for x cubed?
Okay, that was a rules of exponents. I was seeing how many people would pay attention to that. Rules of exponents. If you square that, you get x cubed squared, right? Rules of exponents say when you raise an exponential to a power, multiply the powers out. This is x to the 6th, not x to the 9th. The actual short way, if it's confusing, x cubed squared just means x cubed times x cubed, right? How many x's are there? 3. How many are there here? 3. How many do I have total? 6. So it's x to the 6th. Again, if you remember your rules of exponents, which I'm taking for granted, multiply 2 exponentials together, add the powers. 3 plus 3 is 6. Raise an exponential to a power, multiply the powers together. It's the same either way. Got it? Okay. But again, the only difference would be, instead of square rooting, you would cube root. Go into your calculator, get the answers, and you're done. The last thing that I'll finish with, because the bell's going to ring in a minute. Ultimately, it is your job as a student to see a problem that I write and to solve that problem. X plus root x minus 6 equals 0. What type of equation is that?
Quadratic type.
Sure? Yeah? 3 terms that equal to 0, that's a constant. The middle term, the linear term, is root x. And then we said square that. What's square root of x squared?
1.
Square root of x squared cancels, the square and the root cancel, and you get x. So sure, quadratic in type. It would factor, that's the middle term, so that would be root x. And then you would do the same, plus 3 minus 2. At the end, when you solve for x, you'd have to square everything, right? To go from root x to x. So that's quadratic in type. But that's also a radical, right? So you could solve it as a radical equation. Isolate the radical, bring these to the right, square both sides to get the answer that way. Got it? Either one works. It's entirely up to you. Use whatever method you want other than just plugging it into your calculator. And as long as you can do the algebra correctly and solve it, you're good to go. We good with this? Any questions? Okay, good. Then we will come back to this and do more stuff on Friday. See you then.